It's even worse. Okay, so types of polynomials. Monomial, write that down. That's one term. Binomials, two terms. Trinomials, three terms. Okay. Polynomial, that's for four or more, although polynomial also refers to those as well. But if we have three or less, usually we use the specific name. For the degree, okay, degree, you use the highest exponent of the letters. So we have x squared, y cubed. We add them up for a 5. But if we have like x3 plus that, you don't add the 3 at all. That's separate terms. So you only add within terms. Okay, please complete this chart. Go as best you can. What's type polynomial? Binomial, two terms. Oops. Good. What's the degree? 1, because there's a 1 on the x. That's it. Coefficients? -1. That's the number in front of x. There's only one letter, so there's only one coefficient. The constant is +8. Okay. Well, the next one. Trinomial, 3 terms. So we have 1, 2, 3. Often you want to just separate them right away before you answer these questions. See how I use these lines? I kept the sign with the term. That's really important. So we have degree 3. 2 plus a 1 is degree 3. So the first term is degree 1, the middle term is degree 3, the last term is degree 0. Highest number is a 3. What's the coefficients? -4, but what's the coefficient in front of the x? +1. Good. What's your constant? 12. Okay, keep in mind the signs, stay with the terms. Okay, simplify completely. So you're going to add or subtract. I want you to draw this one, please. I mean draw your rectangles for your x's and your 1 tiles.
God, those suck.
So we... Oh, suck it up. Could have had 2 done already if you seemed complain. Yup, that's why I'm drawing 8 of them. Not trying to be funny, just saying. Okay, so I drew my x's. You complete the drawing, please. Notice how I matched up positives and negatives? Because then I can do what? Cancel out the 0 pairs. Okay, so I have 0 pairs I can circle and cancel out. That's something that we can challenge you on. And then we have 1, 2, 3, 4. Those are supposed to be squares, by the way. We got 5, 6, 7, 8, 9, 10, 11, 12. So then we have 12 1 tiles. So altogether, once we've collected like terms and canceled out 0 pairs, -6x minus 12. Okay, what about without the 0 pairs? Please collect like terms without the 0 pairs. How many x squareds do we have? How many x's do we have? -1x squared and -3x's. Okay. For the next two, you're going to do the same thing, but you have to subtract correctly. So when you're subtracting, you have to subtract both pieces. So you have to minus the positive 5y minus the -8x. When you drop brackets, make sure you add and subtract properly. So what happens to your signs? Yeah, they change. So it's a minus 5y and a plus 8x. Now that you corrected your signs, you can collect like terms. Okay. For the second one, you have to make sure you subtract properly, so change your signs and be very careful because we're going to give you these where it's just a negative sign in front. Okay. Go ahead, do the next two. So the first one, negative 3y plus 18x. Hands up if you got that. Next one, collect like terms. How many x squareds do we have? 2x squareds. How many x's? 0. Do we have to write 0x? No, and we really shouldn't. 4 plus 6 would be plus 10. Good. Plus 5. Oh, right, plus 5, so 15. Hands up if you got that. Good. Okay, one thing to note is the difference between ascending and descending. What order is this? Descending. You go from a high exponent to a low exponent. Okay, please rewrite it in ascending order. So you want to go from your low exponent on the x to the high exponent. So for ascending order, negative 3x minus x squared. Okay, so you switch the terms and the signs stay with the terms. Okay. Any questions about the meaning of ascending or descending? Yep.
So for C, I had got 18x minus negative minus 3y. That be right. So I just flipped it.
Sorry, this one right here?
Yeah, I got it opposite.
But you should have got plus 18x. You could have wrote this as 18x minus 3y. Oh, sorry, I thought you had the signs switched. No, that's good. Nothing wrong with that whatsoever, Kezia. Okay. Good. Okay, next one, multiplying. So we multiply our coefficients, and we also multiply our letters. So on the x, 2 plus 4. Why did I go 2 plus 4? Yeah, that's the rule. What kind of rule is it? Exponent rule, right? When you multiply the same base, add the exponents. What's the answer for this one? Good. Do the next one. Go. Negative 40x squared y squared. Okay. All right. What about when we divide? What do we do with our coefficients? Not our coefficients. Divide our coefficients. What do we do with our exponents? Minus them. Okay, go ahead, do this one. 5x4, hands up if you got that. Awesome. Do the next one, go. Good. Okay. Negative 2x6, y6. Good. Next one here, we have to draw it. So we have negative 2. We should shade those in. And at top, we have 3x minus 7. 2, 3, 4, 5, 6, 7. So we have basically negative 2 groups of that. So what we're showing here is that's negative 2 times the 3x and negative 2 times the negative 7. Altogether, how many x pieces will you have? Well, 6, and it's going to be all negatives. And how many 1 tiles? 14. Are they going to be positive or negative? Positive. Okay. So what we have is negative 2 times 3x and negative 2 times negative 7. Okay. So there's the two parts. Okay, go ahead for the next one. It's 6x times all three parts. Go ahead. So you should get 18x cubed plus 24x squared minus 30x. Hands up if you got that. Awesome. Next one. We want you to collect like terms, but before you do that, you have to multiply in. Be careful, don't multiply in by 4. Right here, what should you multiply in by? Negative 4. Go ahead and do that. Multiply in, collect like terms. So everyone should have 2 lines of work, minimum. Okay, do the next one as well. Multiply in, collect like terms. X cubed plus 7x squared.
Yeah.
Good. Any questions with these two? Okay. Next one, you're going to have a division. Okay, so for your division, it's important to know that what we have is each term on the top being divided by 6y. So really we have 18xy divided by 6y minus 12y divided by 6y. That's a huge concept to understand for grade 10. Okay. And sometimes in grade 10 you can divide one but not the other. Okay. So here at the back we get 2. At the front we get 3x. Final answer, 3x minus 2. Okay. So on the next question, which you're going to do by yourself, we're going to have 1, 2, 3 divisions. Go ahead, do the question. Okay, is that your answer?
Yeah.
Nope. It shouldn't be, because when things divide perfectly, like 4 divided by 4, that's 1. So we got to make sure we write the 1 for our algebra as well. You must have that plus 1 there. Very important. Okay. Sarah?
Wouldn't it just be negative 4x and not the y piece?
Oh, sorry. Yep. Negative 4x. Thank you. Okay. All right, here. What you want to do, see if you can simplify first. Then substitute. Now, we talked about substituting yesterday. What should you be careful of when you substitute, or what should you use? Yeah, use brackets. Okay, go ahead, try these 3 questions. Diagram. So with the triangle diagram, we can ask two questions. One is what's the perimeter, and the other one, what's the area? So for perimeter, we add up the sides. How many sides on a triangle? 3. You should use brackets because that helps you see that you have all 3 sides. Okay. So now I can clearly see I have 3 sides. Go ahead, add them up. I didn't. On what you're talking about.
Now you're lying.
Just call me Miranda. Okay, now you could have written this one as 6x plus 6 times 5x. Did anyone do that? Divided by 2? It does work out to be the same, right? Don't be concerned about that. 5x times the first term times the second one. So you'd still get 30x squared plus 30x divided by 2. Okay. I usually don't write it this way because some people get all scared and cry at night because they see 5x at the back. Alright, but it's no big deal. It's just the same as it's at the front. Okay, so here I'll erase your nightmares for you. There you go. Okay, next. Classic one with the old rectangle. So we have a piece that's missing. We want to find the area and the perimeter. But in order to do that, kind of need that measurement first. So that's the first question. The question is, determine an expression for the segment that's removed with a question mark. What's the distance from this side here all the way across? Good, 5x plus 4. So why don't we then take away this piece here and take away this piece here, because then we'd be left with the question mark. So we have 5x minus 4. What do we need to take away? 2x plus 1. And what else do we need to take away? How did you know that that measurement were the same? Yeah, they're the same because they're the same markings. Okay? So you got to know that they are the same. Good. Go ahead, find that missing piece then. X plus 2?
Yeah.
Good. Okay, next one. Determine the perimeter of the figure, so add up all the sides, please. Go ahead, add up all the sides. Twenty-eight x plus 8. Hands up, you got that? No? What did I screw up on? Did you include the 2x and the 2x? I'd say no. Yeah, you got to include those as well for perimeter. Okay. Okay. Next one, determine the area of the figure. So one of the easiest ways of doing this is you take the area of the large object and you subtract the area that's cut out. Okay. Now we're not going to have enough room for that, so let's do that up here. So the area of the large object is simply length times width. Area of the cutout is still, it's a rectangle, so it's length times width. However, you got to be careful. You should put brackets around the cutout because you need to subtract the entire cutout shape. Not just the x's or the x squareds, but the entire shape. Okay, so for the large area, it's going to be 7x times 5x plus 4 minus bracket 2x times 2x plus 1. Okay. So go ahead, try that, see what you can get. Go. Is that right? So 31x squared plus 26x. There's no plus 1 anywhere. 2x times plus 1 is 2x. Okay. Okay, that's it for notes.